Hello everybody and welcome back to another video. In today's video we're going to be going over low Earth orbit. So first let's just understand what Earth orbit is. So basically what an Earth orbit is just a cycle around Earth. And an example of this could be satellites. Satellites are always orbiting the Earth at all times. And an example of a satellite could be the International Space Station. The International Space Station is part of the low Earth orbit, which means that it's always orbiting the Earth at all times. And another example could be the television satellites. Those are a little bit above the International Space Station. They're in the high orbit. They're in the high Earth orbit. So that's just a general understanding of what the low Earth orbit is and what we're going to be covering in this video. So now let's get started with our first slide, which is just some important words that we're going to be going over today. So some of the things that we're going to be going over today are the low Earth orbit. Second is the Earth's escape velocity. The third is the new Shepard Rocket. And finally, fourth, we have the Geosynchronous Orbit. So these are just some important words that we're going to be covering throughout this video. And let's get started with our first slide, which is what is a low Earth orbit. So a low Earth orbit is an orbit around Earth with a period less than 128 minutes. A low Earth orbit also contains an altitude of not more than 1/3 of the radius of the Earth, which is approximately 2,000 kilometers. So in this picture we can see that we have Earth and we have a bunch of satellites that are orbiting Earth. So this is just an example of a low orbit Earth. So these satellites are just always orbiting Earth. And as we said in the slide right here, it says that a low Earth orbit cannot contain more than 1/3 of the radius of the Earth, and it has to be less than 128 minutes. So now we're just going to be going over a quick video clip of a network that contains a bunch of low Earth orbit satellites.
I'm feeling tired, sticking around while you were gone. You don't deny it. You took me for granted for too long.
So as we explained in the last slide, all of those little dots, blue dots that you saw around the Earth, those are all the satellites and they're all orbiting the Earth in a low orbit. So now let's talk about how you can remain in a low Earth orbit. So in order to remain in a low Earth orbit, a satellite has to travel around 17,500 miles per hour, which is basically just 7.8 kilometers per second. And at this speed, it will take around 90 minutes for a complete Earth orbit. So in order to remain inside of the low Earth orbit, you're going to have to at least travel at 7.8 kilometers per second, and it'll usually take about 90 minutes to complete a full orbit. So that is how you can remain in a low Earth orbit. And now let's talk about satellites and how they stay in our low Earth orbit. So satellites are usually placed around 200 to 800 kilometers above the atmosphere of the Earth, and the International Space Station is exactly half of that, placed at 408 kilometers above Earth. So now let's talk about Earth's escape velocity. So basically what Earth's escape velocity means is how much speed you need to leave Earth's atmosphere, and in order to escape the Earth's atmosphere, a rocket must go at 25,000 miles per hour or 11.2 kilometers per second. So in order to leave the Earth's atmosphere, this is the amount of speed needed, so which is 11.2 kilometers per second. So now we're going to be talking about suborbital rockets. So if an object is traveling slowly, such as the Blue Origin suborbital rocket, New Shepard, it will fall back to Earth just as surely as you do when you jump into the air and come back down. So basically, the New Shepard Blue Origin suborbital rocket was made by Amazon, and it's for space tourism. Basically what their goal is that they're going to launch a rocket which will go into space and it'll do a little orbit around Earth. Well, it won't do a complete orbit, it'll just do maybe, I'm guessing maybe an hour, 2 hours orbit around Earth, and then it'll just come back down. So as we said in this slide, as you jump into the air and come back down, that's the point of this rocket. So as soon as you go up, shortly later you're going to come back down. So that's basically the plan of Amazon for their new Shepard rocket, and this is a picture of how it looks like. So now we're going to be covering what a geosynchronous orbit is. So if we break the word down into two pieces, geo means Earth and synchronous means in time with. So basically it just means in sync with Earth or Earth in time with. So geo is an altitude of around 22,000 miles, which is approximately 36,000 kilometers, at which point the orbital speed has slowed, so a single orbit corresponds to the precisely one rotation of the Earth. So if we look at this image here, we have Earth and we have a satellite. So basically what's happening here is that as soon as the Earth is rotating, that satellite is also rotating at the same direction at the same speed. So if Earth is rotating left like this, then the satellite will also be rotating at the same direction. So, and that's why it's also called geosynchronous, because it's in sync with Earth. And if Earth rotates at 24 hours, then this satellite will also be at the same 24 hours, just like Earth is. And now, furthermore, an orbital speed of 3.07 kilometers per second is required to keep the satellite inside of the geosynchronous orbit. This means that a satellite at that altitude effectively hovers over a single spot on Earth's surface, which makes it especially useful for TV satellites and other communication systems. To stay in the geosynchronous orbit, you're going to need to go in a speed of 3.07 kilometers per second. So basically, why this is useful is because on your TV, you're always going to have that same show running all the time, because the satellite is right above you, and wherever you go at each single time, you're always going to have the satellite right above you, so you're always going to be able to watch that show of yours. And that's why it's really useful for other communication systems and for TVs as well. So let's continue with our geosynchronous orbit, and let's look at a problem with it. So one problem with geosynchronous satellites, for telephone and communications, there is a noticeable time lag during telephone conversations. Low Earth satellites eliminate the lag because they are closer to the ground. So if we look at this picture here, the three bottom satellites, they're basically, we can consider them as our low orbit Earth, and then the three top satellites are our geosynchronous Earth. So although the geosynchronous orbit always has its advantages of being right above your head, there is one disadvantage, which is the time lag. Since the satellite is way further away than the low orbit Earth, it will take a lot of time for a signal to come right back to you. So if it was a low orbit Earth, then it would be right away because it's not that far away from the atmosphere. But then the geosynchronous orbit, it would be really far away, and that's why there's a time lag. And that's basically everything we need to know about our geosynchronous orbit and our low orbit Earth. And that's also basically it for this video. So thank you so much for watching from Try to Be Useful. And please make sure to leave any comments you have regarding to the video in the comment section below, and I will try my best to respond to them as quick as I can. So thank you for watching, and we'll see you guys in the next video.